In this video, we will be talking about how to do questions 1, 2, and 3 from homework 12.3. In each one of these problems, they give you an exponential statement, like 8 cubed is 512, and they want you to write the equivalent logarithmic statement. Let's do some similar problems. So 2 to the 5th is 32. 2 times itself 5 times is 32. The equivalent log statement is log base 2 of 32 is 5. Let's get some color on there. The base of my log and of my exponent are both the same number, right? Remember that that's called the base of the exponent. That's the base of the log. And here, how about blue? Here is the exponent. Right? Log base 2 is going to take in a perfect power of 2 and spit out the exponent. Let's do a little bit of scratch and convince ourselves that this is true. Log base 2 of 32. Well, 32 is a perfect power of 2. It's 2 to the 5th. Those are the same number. And what does the log base 2 do? It gobbles up a perfect power of its base and it spits out that exponent. Let's be careful about memorizing a movement. I've seen a lot of movements where people start with the base of the exponent, go to the other side of the equation, and come back up to the exponent like that. If you are needing to initially try memorizing a movement, then you're going to want to always write your exponential on one side of the equation and it's simplified in a numeric form on the other side. So if you always write it that way, you can do a movement. We want to move past that and read for understanding, but I totally understand if that's where we want to start. The base of the exponent is the base of the log, going to the other side of the equation, and then coming back to the exponent. The log is going to spit out that exponent. Let's do a handful more. How about 5 cubed is 5 times 5, which is 25, times one more 5 is 125. The equivalent logarithmic statement will be log base 5 of 125 is equal to 3. The base of your exponent and the base of your log are the same. The log is going to spit out the exponent. Right? Why is this true? This is taking some getting used to reading. Log, I'm just going to do a little scratch to convince ourselves this does make sense. Log base 5 is going to take in a perfect power of 5, that 125, and spit out the exponent. 125 is equal to 5 cubed. Log base 5 is going to take in that power of 5 and just spit out that exponent. Oh yes, this does make some sense. All right, I'm going to do a few more of just writing the equivalent log statement, but now not doing the little bit of scratch, just to get some traction. So if I say 7 to the minus 2, well, that's the reciprocal of 7, squared, right? 7 to the minus 2 is a 49th. The equivalent log statement, right? The equivalent log statement is log base 7 of a 49th is minus 2. The base of the exponent and of the log are the same. The logarithm is going to spit out the exponent. All right, let's do 2 more. 3 to the 0 is 1, so log base 3 of 0 is 1. The base of the exponent and the log are the same. The log is going to, oops, Lindsay's dyslexic, you can laugh at me. Log base 3 of 1 is 0. I'm so sorry. The log is going to spit out the exponent. It actually doesn't make sense to have a logarithm take in 0 because an exponent will never spit out 0. I apologize for my misspeak. So let's do 2 more because I misspoke. How about 2 to the 4th is 16, so log base 2 of 16 will be 4. The base of my exponent and my log are the same. Logs spit out the exponents. Log base 2 is going to gobble up that perfect power of 2, of which 16 is. It's 2 to the 4th, and it'll spit out the exponent 4. All right, how about one more? 25 to the 1/2 power. Remember, that's notation for the reciprocal, or sorry, the square root of 25, right? And the square root of 25 is 5. The equivalent log statement will be log base 25 of 5 is 1/2. The base of my exponent and my log are the same. Your logarithm spits out the exponent. All right? So I hope this video helps you with questions 1, 2, and 3.